we will look at evaluating functions. So when we evaluate functions, all we're doing is plugging values in for the variable. So you may have evaluated functions before without even knowing. So for instance, the old way, I'm going to put that in parentheses. The old way may be if 3x plus 2, then x equals negative 5. Well, you'd plug negative 5 in for x. Well, the function way would be f of x equal 3x plus 2 if f of negative 5, or find f of negative 5. So that just means we're going to take negative 5 and plug it in for x. So really it's nothing different, you're just looking at a different format of evaluating our functions. So for instance, if we have ht, we have absolute value of t plus 2, and then you add 3, we're going to find h of 6. So we're going to say, well, h of 6 equals absolute value of 6 plus 2, and then we're going to add 3 to that. So h of 6 equals absolute value of 8 plus 3. Absolute value of 8 is 8, and then add 3 would be 11. So you're thinking, okay, well, what does this really mean? Well, in a graphical way, if we graphed this, it would look like a V, and it would be in a different spot than the origin. This is saying that the point 6, 11 is a point on the graph. That's all that this is saying. If h is 6, well, what is y? Or what is the value? So you can actually say, well, find h of negative 2. Well, h of negative 2 equals absolute value of negative 2 plus 2, and then add 3, so we'll have 0, or absolute value of 0 plus 3, which equals 3. So on a graph, if you graph this out on the graph, the point negative 2, 3 will be part of the line. So if I graph this real quick, our graph will look something like this. So at negative 2, we will be at 3, and there we are. At 6, we will be all the way at 11. Let's say, well, how about h of 0? h of 0, so we have 0 plus 2 plus 3. 0 plus 2 is 2. Absolute value of 2 is 2. We get 5. So that means 0, 5 is a solution. So if you look, here's 0, here's 1, 2, 3, 4, 5, and there is a point on that line. So that's all that function notation is. Where is, we have this as x, now where is the y, or how can we solve for this function? So let's go ahead and look at some other ones. So f of x equals x squared minus 3x. We're going to find f of negative 8. So f of negative 8 equals, so plug in negative 8 in for x. So we'll have 8 times 8 is 64 plus 24. That will equal 88. So if f equals 8, then our output is 88. And that's another way you can think of this. This is the domain, this is the range. This is the input, what's the output? So beyond just plugging in values or numbers straight in, we can actually solve for or plug in polynomials. Okay, one way we could, the reason why we could do this, or one reason why we would do this is if you were to change the location of your graph. So anyway, we will have p of t minus 2, so 4 times, instead of t, we're going to write t minus 2, and we're going to subtract 5. And then we solve, or we simplify in this case, because we don't have a direct value for t. So we have 4t minus 13. So this is saying if we want to take all the t values and subtract 2, or move all of our x values down 2 or over 2, excuse me, change their values and subtract 2 from everyone, well, where is our new graph going to be? Well, here's our new graph. Which a lot of this graphing stuff that I'm talking about, you may or may not understand it, and that is okay. It's just a little more FYI for your information. Let's see here. We will work on, let's look at h of n equals 3x squared plus 1. We're going to find h of negative 2n. So no matter where you find an x, oh, I don't mean, let's change this to x. My variables didn't match up. So h of x, we want to change it to negative 2n, or find what negative 2n is. So 3 times negative 2n squared plus 1. Order of operations, 2 squared, or negative 2 squared is 4, n squared plus 1. 3 times 4 is 12, n squared plus 1. Okay, and then one thing I should mention or show you, this p of a equals a squared minus 5 if p is x minus 4. Okay, so wherever you find the a, you're going to plug this value in. So p x minus 4 equals x minus 4 squared minus 5. Do not distribute that. This is a exponent, and we're bound by subtraction, so we have to copy and paste two times, and then FOIL. So x squared minus 4x plus 16 minus 5. So you have x squared minus 8x plus 11. So when we take our x values, or in this case our a values, and subtract 4 from them, we will actually get a graph, or our graph will move. So if x is x minus 4, our result is x squared minus 8x plus 11. And this is probably really hard to wrap your mind around, but the basic thing is just whatever value you have here, you plug it in for your variable, and then you simplify. This concludes this video.